Josh rode his bicycle from his house to his grandma's at a rate of 10 miles per hour, and later he rode home at a different rate, 15 miles per hour. So let's just draw a quick picture. Okay, here's his house. He goes to grandma's. This is grandma's house, and then he goes back home. Does the distance change, guys? Distance is exactly the same. The only thing that changes is the rate, how fast he pedals. It looks like he goes faster going to grandma's and a little bit slower going home. You do need to know that distance equals rate times time. So, we know that the distance for this part is going to be exactly the distance for the next part. So we know that the rate in which he goes to grandma's is 10t. And the rate at which he goes home is 15t. Now these t's have to add up to what amount? Can anybody tell me? They have to add up to 30 minutes, correct? Well, here's the problem. We're talking about minutes here, but when you look up above and you talk about how fast he goes, what unit are they using for time? So let's change and go from 30 minutes down to hours. What is 30 minutes in terms of hours? What is 0.5 of an hour? Okay, 0.5 an hour. So go up here and change this to 0.5 of an hour. Now we have the same time unit when we talk about the rate and we talk about the time. All right, so let's just talk about this really quick. We know it takes 30 minutes, right? So let's think in terms of 30 minutes. If I tell you it takes him 20 minutes to get to grandma's, then how many minutes would it take him to get home? I know this is not true. I'm just seeing if you guys can get this. 10 minutes. If I told you it took him, let's say 18 minutes to get to grandma's, then how many minutes would it take him to get home? 12, because they have to add up to. Okay, so I'm going to let t be the time that it takes him to get there. Then this t, how would I figure out this t? It would be, there is a minus involved. Okay, let's try this, guys. If this is 10 minutes to get to grandma's, then how long is it to get home? 20. How did you get 20 in your head? What did you do? You subtracted from what? 30. So 30 minus whatever this first t is, right? But we're not going to use 30. We're actually writing it in terms of hours, which is 0.5. So write 15, and then this part is 0.5, subtract t. This is the way to go home from grandma's. This is the way to get to grandma's. They both describe distance, and they describe the exact same distance, so we can set them equal to one another. So I'm going to distribute 10t equals, please take 0.5 times 15, please. Do you end up with 7.5? Now I'm going to take and combine the t's, so when this negative 15 comes over, I'm going to add it. Now to isolate the t, I'm going to divide both by 25. Please take 7.5 and divide it by 25 for me. What do you end up with? A little bit louder so I can hear you. 0.3. That represents the time. Let's go back up to the top. 0.3 is the time. Let's talk about Josh going from home to grandma's. Remember, distance equals rate times time. So he rode at 10 miles per hour, that's his rate, and he had a time of 0.3 hours. Please take 10 times 0.3 and you'll get the distance. 10 times 0.3 is 3 miles.